In this video, we'll be talking about the area of a rectangle. Once we've established the formula for the area of a rectangle, we'll use it freely to establish the area formula for other shapes, such as the triangle, circle, parallelogram, and trapezoid. So here we'll focus on developing the formula, and in future videos, we'll be extending the formula. First, let's start with our most basic understanding of area. We'll have a standard repeating unit. Here we're going to have a 1 centimeter by 1 centimeter square, or a square centimeter. We're going to line those up without any gaps or spaces, and we can use that to determine the area of our shaded rectangle. And what we'll do on the most basic level is just literally count up those squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our area is 15 square centimeters, or 15 1 centimeter by 1 centimeter squares. You can imagine that for a large rectangle, we could have very large numbers for our area, so we want to get more efficient, and that's where multiplication comes in. So still I have my repeating 1 square centimeter here, but instead of counting them up, I'm going to view this as rows. So I have a total of 5 rows. 5 rows. Each of those rows contains 3 of my square centimeters. 5 rows of 3, that's the same as 5 groups of 3, 5 sets of 3. This is our understanding of multiplication. 5 times 3. I could also view this as an array. I could have a 5 by 3 array of squares. Again, that's still multiplication. My first example here, I had a whole number of squares. These ideas work for fractional amounts of squares too. So I can outline my square units here. And I can break them up into 2 groups. My first one, you can see that I have one group that contains 2.5 squares. The second group, I've just cut this first group in half. So my total is 1.5 groups of 2.5 square units. And I can multiply those together to get the answer. I could have also gone back to my basics and just counted. Now that we know we can relate our area to multiplication, let's get a little bit more sophisticated. So we're back to our basic square here, where we have a 5 by 3 array of square centimeters. Let's relate this to 1D measurements. I'm going to call this my width, and as a one-dimensional measurement, it's 3 centimeters. I'll call this my length, and as a one-dimensional measurement, it's 5 centimeters. So notice with my area formula, length of 5 centimeters times width of 3 centimeters right here, I can rewrite this as 5 times 3, 5 by 3, and centimeters times centimeters is going to give me our 5 by 3 centimeters squared, or 15 square centimeters. So I can take those one-dimensional length measurements and relate them back to our square centimeters, back to either just multiplication or counting of squares. So from this point forward, we can freely use our area of a rectangle formula because we know it's not just math magic, length times width. We can relate it back to basic fundamental ideas of mathematics.